everyone for joining. We're really excited to be discussing chemical monitoring in the field today with a couple of experts joining us from the Pacific Marine Environmental Lab. We'd like to welcome back Dr. Sutton, but also welcome Sophie Chu. Do you both want to say hello and share a little bit more about your work?
My name is Adrienne Sutton, and I'm an oceanographer at NOAA's PMEL laboratory in Seattle in the US. And I've been running a monitoring program for NOAA for a little over a decade. And we do autonomous observing of air sea CO2 flux and also seawater pH on buoys around the world and also on autonomous vehicles. Yeah, I'll leave it there. Go ahead, Sophie.
Sorry, my video and audio is a little bit lagging, so if I am slow to answer, that's why. My name is Sophie Chu. I work with Adrienne at NOAA's Pacific Marine Environmental Laboratory. My focus is on developing and testing new carbon sensor to deploy in the ocean. And I've been working with the Ocean Foundation for a few different workshops in the last 4 or 5 years. And happy to answer any of your questions.
That's wonderful. We're so happy to be joined by you both. Thank you for taking the time today to share your experiences and to complement the great lecture that you gave this week, Dr. Sutton. For everyone joining, thank you for joining us. Like always, if you have any questions, please feel free to raise your hand and unmute yourself, or you can put your questions in the chat, and we'd be more than happy to discuss them. Also, as a reminder, if you're applying for a Go on a Box kit and thinking about what your sampling strategy might look like, this is a really excellent forum to get some feedback. No matter how new you are to this, we're a welcome group to sort of bounce your ideas around. Our goal is just to do good science together, and so this is an opportunity to discuss that in more detail. I'm curious actually to hear from the participants that are here today. Maybe you can either mute yourself or put this in the chat, but is there any sort of monitoring that you already do out in the field? Do you go out and take samples for water temperature or phytoplankton or do any fish counts, things like that? It'd be really interesting to hear what your time on the field may already look like if you do that. And then we can think about how you might integrate chemical monitoring into those sorts of days in the field too. So looking forward to hearing more about your stories in the chat or if you raise your hand. But in the meantime, we can launch into some questions to get us going from our experts here today. One thing that I'm curious about is what kind of sites are easiest to measure for those who are new to carrying out carbonate chemistry monitoring? Is it best to find like a featureless sand flat, that perhaps doesn't have as many outside influences on the carbonate chemistry system? Or can you start off in a really vibrant habitat like a coral reef that potentially has a lot of different drivers for the carbonate chemistry system?
Yeah, I can start off with that one. So I would say that and I'll probably repeat this again this hour, but your sampling strategy should really rely on what your research question or hypothesis is, or what your expected outcome is. And you have to balance that with the constraints you have, in terms of ship access or funding or instrumentation, and also what opportunities you have, whether you're already running a monitoring program where you're monitoring temperature already, or maybe nutrients already. And if you were just to add on ocean acidification measurements, that's quite a great leverage opportunity. And so I would say that that's probably would be the priority, is kind of starting there with those two things. What are your research questions? And then what are your restraints, constraints, and opportunities? You know, in terms of ease of data interpretation, you know, I think that's where your question was maybe going at. You know, if you're starting in a very vibrant coral reef community, you're going to see a lot of variability in your data that may be challenging to interpret when you start off. Although that will get more straightforward as you collect a long-term record there. You know, I have some other people who have been trained to use the Go On in a Box kit. I know one example in Mauritius where they had a small boat, and so they have established a monthly sampling strategy where they sample in the near shore, and they have, you know, a handful of sampling stations where they start in the near shore and they go out into by the coastal shelf where their end point is open ocean water. And so that open ocean water has less variability, and that can also often help them interpret the data that they're gathering in shore. So that's one example of that.
That's really neat. I'm curious if you can share a little bit more about the advantages of having those different points, you know, further and further off the coast. Can you see evidence of upwelling, or, you know, what other processes does that allow you to get more insight into by setting up these sampling stations, you know, at a distance?
Yeah, one of the big benefits of having a monitoring strategy where you have an endpoint in you know, out of the coastal water, is that you can then tie your data set to a lot of the already available data sets for the open ocean. And then you have, you know, a benchmark, you have, you know, something to tie to other data products that you can use to quality control your data. So that's really a good benefit of that. And that open ocean water is also, you know, not impacted by a lot of the drivers that impact the near shore, right? It's not getting a lot of impact from the coral reefs or river runoff or, you know, all of those coastal processes. So it's much more of a, you know, you'll find less variability and more stability out there. Sophie, you have anything to add to that?
I think she's got her audio set up right now, so we can move on to the next question. Curious to hear a little bit more. Oh, yes.
Okay. Sorry, Adrienne, I was trying to line up my audio, so I didn't know what you were saying, but I caught the end of it and agree.
Perfect, thanks. What are some other considerations that are important for identifying a good site? Like, how do you reduce interference from other ocean users, right? In the coastal environment, you know, there's a lot going on, whether that's fishing or recreation, tourism, things like that. When you're figuring out where to put your instruments, which can often be quite expensive or potentially sensitive, what do you look for to, you know, find that site that is probably most likely that they're going to be happy over the next couple of months while they're out there?
Do you want to start with that one, Sophie?
Sorry, can you briefly repeat that?
Yeah. What makes a good site or good consideration when you're looking for a site to put your instruments down to begin monitoring, to help reduce potential interference from other coastal activities like fishing or tourism. What do you look for in order to find a site where you know you're going to come back in a couple of months to service your instrument and feel confident that it's still going to be there collecting good data?
Yeah, I think Adrienne was also talking about this. It totally depends on what your question is. I can talk about in my PhD research, I was working in a salt marsh, and there are salt marshes that are really affected by eutrophication and nutrient input. But we were trying to get a baseline kind of like carbon flux. So we tried to choose a salt marsh that had the least amount of nutrient input. And in terms of making sure like people don't kind of mess with your instrumentation that you put out there, we didn't really have to worry about that. It was kind of like a remote location. They did build like a boardwalk, so people could potentially walk out there if they wanted to, but I think it was kind of obvious from the infrastructure that it was like a science experiment, basically. I know people put signs up. I think Adrienne can talk about like the moorings out in the open ocean and how sometimes they get fishermen. But what I don't know the story, but the Peggy buoy, Adrienne can jump in.
Sure, I can tell that story. And the take-home message of this story is that you really need to know who those users are and understand, how they may interact with the equipment out there. And so outreach to those communities is really important, developing a relationship with them, understanding, what their needs are and what they're looking for in terms of information from the ocean. So there's one example where, so buoys, if you have a surface buoy in the ocean, if you have any platform in the ocean, fish aggregate to it, they're attracted to it. And that means fishermen also are attracted to it. And oftentimes, fishermen can be pretty destructive to surface buoys. And they were finding that this was happening a lot in Alaska. And in Alaska, there's this great story of a fisherman's wife whose first name was Peggy. And she would get on all the fishermen's radio every day and report the weather for them. And she ended up being very beloved by that community because she often saved lives by providing that information. And so what NOAA did with these buoys is they started a conversation with the fishermen about how these buoys are so important for weather forecasts. And they ended up painting the name Peggy on the side of these buoys. And so whenever fishermen would see that, they wouldn't touch it because, they knew the importance of that name, and then they understood the importance of those buoys. So there's just kind of one story that will help in that kind of, those kind of issues with your equipment. And I guess the other just like really practical, boring thing that I would mention is that some areas you may need a permit to deploy oceanographic instrumentation in the coastal zone. So that's another thing to make sure you look into as well.
Those are such good considerations. When I was trying to do sampling for my PhD work in some seagrass habitat, I had the thought of working outside the marine protected areas so I could eventually collect organisms there. and had challenges with lots of tourism in the area. I didn't feel comfortable like leaving out sensors over a long period of time. And we have folks that are tracing through and like digging through to try to find cool animals, which of course, we're always excited about as well. So I eventually just, went out and did my own sampling multiple times a day over a certain time period, which did not get me, the fine resolution of data that would have been ideal. So these are, great pieces of advice for actually how to work with those considerations and create those that long-term sampling to get the data that you need. Another question that I have is, sometimes equipment has to be removed for servicing, whether that's calibration or just getting off the biofouling on it. That can be planned or unplanned too. Perhaps something fails and you need to take it out of the water. How do you deal with these gaps in data in the time series? Can you figure out some sort of way to interpolate between data points? Is that a bad idea? Is that risky? Do you ever pull instruments before servicing potentially because you're going to have to service them eventually and you want to make sure that they're back in the water for an important event like coral spawning or something like that?
Yeah, I would say yes to all of those things under certain considerations. Within our monitoring network, continuous measurements are really important for our science questions. And so we've prioritized that and built that into our program, including the funding structure. And so, for every site that we maintain, we have 1.5 to 2 times the amount of sensors in our equipment pool for that site. And so when we have to replace a sensor, we have another sensor to replace it with at the same time we're pulling that sensor out. And so that's how we've dealt with that issue. You have to consider, if you need a full refurbishment that the company needs to do, you have to consider the time it takes for that, right? If you're sending that sensor back to a company in another country, it's going to have to ship, it's going to have to go through customs multiple times. Then you have to get the funding to them, and then it takes them a certain amount of time in the lab to refurbishment, and then it has to turn around and go this other way. So there can be big gaps if you just have one sensor. But it depends on your science question. Maybe those gaps don't matter. Maybe you're only interested in the coral spawning period, and which is a certain time of year, and you have your sensor out that year, and then you get it, maintained by the company, and then you get it back. So, one strategy is to have more than one sensor. In terms of interpolating gaps, again, that depends on what your science question is. So, yeah, it's possible. It's just, yeah, it depends what your questions are. Yeah, Sophie, do you have anything else to add to that?
Just that people understand gaps in data, especially if you have already, if you have chunks of like high frequency data and then you have some chunks of missing data, then people know that that's because either the instrument wasn't working or you had to do some servicing or something. So, yeah, I mean, if you're looking at coral spawning or something in a very specific time, then you definitely want to have your sensor out then. But if you're, yeah, I don't know what else I was going to say with that.
Oh, that's a really good point. Thank you both for that. To the point about having backup sensors and the time and it takes to send things back for servicing, that's something that we're working on for those who are going to be receiving Go Out on in a Box kits with this project. So for those of you who attended the Q&A or the informational session the other day, you learned that we're thinking about how to include extra instruments. So you can either potentially increase your ability to sampled multiple times at one point, or have a backup in case you have to bring something back for servicing. And then we've established a Pacific Islands Oceanification Center in Suva, Fiji, that will have spare parts. So hopefully that reduces some of those long periods of time where you might otherwise have to send one of our sensors back. It's from Montana, here in the U.S., so quite inland, very far away. And yes, customs back and forth can take quite a bit of time, but that's something that we're thinking of continually to try to make it a little bit easier to get those continuous data sets, if that's part of your research question.
Yeah, and I'll
That's a
just
good
add
point.
that if you have a sensor in a nearshore environment that you can get to and occasionally check it for biofouling and clean it, if it has an optical surface that's going to be impacted by biofouling, or just getting the crud off of the outside of it is often good best practices. If you can do that, it'll make the sensor last longer.
Are there tips and tricks to reduce the amount of biofouling on your sensors, to avoid having to bring it back to the lab and scrape all that off?
Yeah, there are various, well, I mean, one thing that we do is we buy we have a copper tape, really thin copper, that we tape onto the outside of sensors. And that just makes it easier to then get all of the junk off when you bring it back to the lab. It doesn't really, I mean, it prevents it from growing for a little bit, but it ends up growing on there eventually, but at least you can just rip it off. Because a lot of our sites, we deploy sensors for a year or more. And so they can come back with, big, mussels and barnacles on them, and it can be a real mess. But there's also, if you have ever used a CTD, there are versions of those that have a pump attached to it, and that pump has an antifoulant in it. And so whatever water goes into the sensor, it's going through an antifoulant and hopefully killing a lot of the critters that are going to biofoul the sensor and degrade the measurement. And so there is a sensor out there that's called the CFOX that a company called Seabird sells, that is a CTD with a pump, and it pumps through a pH sensor. So that's another strategy. Of course, those sensors are much more expensive than the iSAMI. So yeah, there are sensors out there like that. There's also a sensor out there that's really new on the market from a company called A&B. That's a pH sensor, and they measure pH over an optical surface. And if that optical surface gets, biofouled, then that degrades the measurement. And so they're working on putting on what's called a biowiper, which is pretty common on fluorescence sensors. That is basically, a little shutter on the top of the instrument that opens when you need to make a measurement and then closes when the measurement's done. And so nothing can grow on it. So there's a lot of technology out there. I guess another technology is UV light. So some sensors now are integrating UV light to keep things from growing on a sensor surface. But all of those are expensive solutions to, frankly, just swimming out there and with a cloth wiping it off.
Yeah, definitely. Thank you for sharing all of that. Sophie, you added in the chat that making sure that you test the sensor before you deploy it is really important. And I know you're familiar with the ICME pH sensor that's included in the Go on a Box kit. So I was curious if you could tell us a little bit more about your process of testing before you put it out there to make sure you're going to have data when you go back in a couple of months to pick it up.
First, I'm going to say for the biofouling convo, filtering, putting a filter on like before it goes into your instrument is really important. When I was working in a marsh, we had like a big like filter for like big things. And we used pantyhose to like keep big pieces of things out of the instrument. And then there was like a smaller, finer filter right before it went into the instrument. So that big filter was just, you know, we found some like, I think it was like a sewing, like a rectangle of a like crochet thing or something. And we just made it into a cylinder and then covered it with a pantyhose. So it was like a probably pretty cheap filter that people could make. But the smaller one was probably a little more expensive. And then for the ICME, yeah, so testing it in the lab. So I would test it first, not in any water. Just make sure you can, that it's actually working. And then testing it in some fresh water, and then testing it in seawater. So there's like levels of, you know, when you test it in seawater, that's like or I guess depending on where you're going to be, your field site is. So you might not be able to have to test it in seawater. But yeah, making sure that it works before you put it out there. You know, I would do like at least a few days of measurements, maybe like depending on the frequency that you're going to be measuring or what question you're asking. Making sure you have like enough batteries in the instrument before you put it out there. For like local deployments, you could probably go out there and like replace batteries periodically. But yeah, and then the ICME, making sure that the reagents that are in there are, you know, going to be enough for however long you're going to be deploying it for.
Yeah, those are great considerations. And for those that do receive a Go on in a Box kit after a successful application, as we mentioned, we'll have a hands-on training at the Pacific Islands Oceanification Center, you know, after everyone has received their instruments, so that you can learn how to use them and check all these things, the reagents, you know, sampling frequency, battery life, etc., so that your deployments are successful once you get back to your lab and start your monitoring projects. One thing that I'm curious, I want to say also, Sally, that's an interesting idea in the chat about chili oil. One thing I love about ocean science is that there's so many cool new ways to solve a problem. Right? Sometimes they're relatively simple and cheap. That's really interesting and sounds like something that's doable. So thank you for putting that in the chat. Again, everyone, if you have any further questions, pop them in there. If you want to share other tips or tricks that you've learned too, that's really interesting to hear about. One thing that I'm curious for both you and Adrienne and Sophie, do you have any considerations when setting sampling frequency on an instrument? You know, how do you determine what sort of time scale you need to be sampling on, whether it's hourly data or daily data? How many instruments also allow you to sort of set these sampling frequencies? Is it sort of set on many of them, or do you have some ability to tinker with the collection frequency?
Why don't you tackle that one, Sophie, and she could give some ICME specific advice for that.
Yeah, so again, it will depend on what your question is. for coastal deployments, you're probably going to want a sampling frequency of hourly or 2 hour. I mean, it's so hard because it's because sampling these deployments you're limited by your battery, right? So your sampling frequency, you want to be able to deploy it as long as possible and also get as many measurements as you can, but you have to weigh it with how long your battery is going to last. So if you're trying to get like a seasonal, like a spring bloom or something, and you want it to last for 3 months, and your battery, you have to think about how long your battery is going to last if you do hourly or 2 hourly or 3 hourly. But I would suggest hourly if you can, since coastal variability is so high. And I mean, even half hourly if you can deal with that, if you can get out there and like replace the battery or replace the reagents during your deployment.
You can also do test deployments where let's say your research question or, what you want to get out of this is you want to understand what the seasonal cycle is and the annual mean. And you just want to track those two things over time. You could, for a year, try and collect high frequency samples, hourly samples. And then after that, you could analyze that data set and figure out at what time of day would you capture the daily mean. And from that point on, you could just have one sample per day throughout the year, and that would get you a pretty good seasonal cycle and annual mean. So, you can kind of experiment with it too and play around. So, first, what's your hypothesis and what's your expected outcome?
Yeah, that's such a good point.
Just to hop in there again, a lot of people do in coastal zones is like a high tide sample, with bottle sampling. They do like a high tide sample and a low tide sample. So that's every 12 hours, right? Well, I guess, it depends on your site actually. So, having measurements of like the water level is also important, and like flow. So if it's coming, like incoming or outgoing. So a lot of places in the U.S. have these like monitoring, tide monitoring stations that have the tide level, and I don't actually know if they have flow, but I think you can usually tell like if it's going to be incoming or outgoing tide. Just water level.
I don't think we include this in a go on in a box kit, but I know sometimes there are instruments to look at current. Do you have any recommendations for what might be useful for those who are perhaps studying like the dynamics of water flowing across a coral reef or in a seagrass habitat?
I've suggested that to my peer-to-peer mentee in Fiji when she was doing I think it was a mangrove or seagrass or mangrove site. But even so, you don't have to have like it would be nice to have like a sensor to tell you the water depth, but I suggested just putting like a yardstick out there in wherever in a location, and at least you can tell what the water depth is kind of from that. And you should be able to tell also like which way the water is going if you're out there. Depending on how, like, yeah, so this is all site specific. So if you're in like a channel or something, you can tell very clearly which way the water is going. But if you're kind of like in an open area, it might be harder.
Yeah.
Sorry, was that your question?
Yeah, no, that meets it. Something I had also heard when I was a graduate student is that folks used to use like plaster, like some sort of, just bulk object, and they would measure the plaster dissolution over time. They sort of get a sense of water currents. I have no idea if that's an actual, thing that is in practice right now or the best methodology for doing that. But I think there might be, sort of a range of different approaches for understanding some of the other dynamics that are perhaps influencing your study site. Cool. We got a question in the chat from Jeremiah. He asked, is it okay to carry out samplings at nighttime? If the same samplings are carried out in the daytime, would the results be any different?
Yeah, if you want to carry them out and if you want to sample at night, then it's fine. And it would be different. I mean, it depends on what you're studying, but I mean, there's a lot of like photosynthesis is not happening at night and there's more respiration, right? So the chemistry is definitely different at night versus the day. I would just say be careful if you're going to be sampling at night because it's dark. And there were probably not a lot of other people out there. This was, in retrospect, this was like probably not very safe, but I remember in my PhD, like sitting in my car, like in the middle of the night or like at 2 or 3 a.m., like in the estuary and going out there and sampling. So definitely it's people, there's probably a bias in sampling because people don't want to be sampling at night, so that those samples are valuable. But yeah, just try to keep in mind safety.
I have a similar experience to that study that I was talking about where I was trying to understand the dynamics of a local seagrass habitat because that's where my lobsters lived. And so I was going out, early in the morning before the sun rose, middle of the day, sunset, and then, the middle of the night, and had that same experience, right? It's a little bit scary to go trucking off into the waves with a Niskin bottle in hand when it's pitch black. And so safety first is always really important. But that might be a place where it's really good to deploy instruments if you can that do that sampling for you and help you understand those sorts of day-night dynamics that you might get in the environment that's dominated by photosynthetic or autotrophic organisms, to sort of see those differences throughout the day-night cycle. That's a really good question. Thank you, Jeremiah. One thing we've been chatting about a lot are different sensors, different instruments. Adrienne, in your lectures, you talked about what has been developed to measure different carbonate chemistry parameters and perhaps what is still needed in the field. So I was curious just to hear a little bit more about your perspective of the work to develop new sensors. What's sort of on the horizon? What do we still need to work on? What makes it hard to measure all of the carbonate chemistry parameters in a platform that's just out in the ocean doing its thing?
Yeah, there are new sensors on the market or on the horizon, but the development of those sensors is incredibly slow moving. The ocean sensor industry can't compete with, let's say like the, food development industry. We've adapted pH sensors that's used in the food industry to use in the ocean, right? But that R&D funding is just so small because it's such a cottage industry. None of the ocean sensor companies that you buy sensors from really make a profit at all. It's just kind of squeezing by. So it is really slow going and it's really difficult. And I mean, for me, it's, you know, I am most interested in getting away from pH sensing, because measuring surface or measuring seawater pH is incredibly challenging, and the uncertainties in the measurements are very high. And so we've been working on instruments where we can measure CO2 and dissolved inorganic carbon. That pair of measurements are a really robust pair for calculating the rest of the carbon system. And so I think that's the focus of a lot of developers right now. How can we develop sensors that measure two parameters, not just one? Because to understand the whole ocean carbon system, you need two of those parameters. But it's challenging. And, you know, this is why these sensors end up being so expensive and unattainable for so many scientists, just because you know, the industry we're in is so small. Sophie probably has more perspective there too.
I'll just share that, you know, here at the Ocean Foundation. Oh, you can hop in if you'd like.
Sorry, I keep forgetting that I have to like go on my phone. I think Adrienne captured most of my thoughts as well.
Yeah, it is a challenge. We're working with a professor at Oregon State University to fund the development of a low-cost PCO2 sensor. We're calling it PCO2 to go. And it's been, you know, a process over the last couple of years or so to find a way to manufacture these. Right now, we're building all of them by hand. It's not at scale yet, but a way to make it low cost, but also, you know, something you can take out into the field, something that gets you high enough quality measurements. And right now we only have that one parameter, right? So it is really that challenge of then finding the second instrument that would go along with that to create a really good measurement system.
Yeah, and I guess another perspective I'll just add in here is I think people tend to really gravitate towards autonomous sensing, and they want that sensor. But just a warning that, you know, if you really get into autonomous sensing, you don't go in the field anymore. You sit at your computer and you analyze lots of data. And so is that the reason why you got into this work? And, you know, so when you get your go on in a box kit, enjoy collecting those bottle samples out in the environment you work in, because I miss that a lot. So there's another warning about sensors for you.
I love that piece of advice. Yes, it seems like, you know, the further you get along in your career, sometimes the more you are parked at your desk instead of enjoying the natural resources that really brought us to this field in many cases. Speaking of cool marine life, Wycliffe had a question in the chat. He says, do you have any experience with marine life, such as curious sharks, disrupting deployed equipment?
Yes,
I know we talked
curious.
about biofouling. Perhaps there's other more charismatic fauna out there too.
Curious sharks have snapped our buoy lines before. So that's an expensive shark bite. They now have material that is resistant to really sharp teeth that we use. But there's one example. We have gotten SAMI pH sensors back, and when we take the reagent bag out, we've found a fish in it before. So somehow a tiny little fish got in there and survived, and that was interesting. Yeah, I'm sure Sophie has some stories there too.
I have never dealt with like megafauna. But I was just thinking how that fish being in the reagent bag must have messed up the measurements.
Yeah, I don't think the SAMI was working at that point.
I just to talk about a little bit about the previous question, like I think like, oh, we could just like go on Shark Tank and like pitch some, you know, instrument and get them to fund it. But yeah, the field is so small, there's no way like it would get any, you would have like sales of like maybe five instruments a year or something like that.
Yeah. Sometimes
Speaking
there are
about sharks.
big pushes to fund new instruments, right? Which I think we've gotten out some cool instruments from that over the last couple of years, like the X Prize challenge, for example, has been beneficial. But that is, you know, so true, is that we are a relatively small community working on this, and hopefully we maintain our sensors to continue lasting us for a couple of years and not having to continually replace them. Yeah, thank you for those questions. I'm curious, we have one coming in the chat right now. London asks, is it sufficient to conclude that data collected at the surface represent different depths? Which I think is a really good question to ask. Thank you for sharing that.
I'm not sure.
I think it depends on how deep your water is and how well mixed it is.
I see. Yeah.
How deep is ice sand go again? I can't recall off the top of my head, but it's relatively shallow, right?
It's 3 meters.
Okay, so that is near surface.
Yeah.
What are some of the ways that you can then, you know, measure different depths? Is it just a matter of taking Niskin bottle samples at, you know, different depth points, or is there sort of a way to maybe take one at the surface and maybe one, you know, at the bottom and estimate what's going on in the water column? What's sort of your process for understanding, you know, different dynamics across different depths? Or perhaps most of your instruments are near the surface. They're on a buoy or at a defined depth, you know, and they're deployed out for a period of time.
I think even with 3 meters, say your deployment site is 3 meters deep, there could still be differences between the surface and the bottom. So maybe something that people could do is when you're taking a bottle sample to validate your sensor, you could take one at the surface and at the bottom for, you know, for every, depending on how often you're going out, maybe like a couple times a season. And then if you're seeing that you're getting the same values, then you can maybe assume that the site is well mixed from the surface to the bottom. Adrienne, do you have more?
Yeah, you could, you know, read about a program called the GoShip program, and they spent a lot of time thinking about this, and they do these, you know, they collect observations in the open ocean, and their strategy is to collect collect bottle samples at more locations in the surface ocean where there's a lot of spatial variability in the water column. And then as they get deeper, their sampling depths get further and further away from each other, because that's where the variability starts, you know, getting lower and lower. So you don't need as many bottle samples down there. So that's the kind of strategy you could do in the coastal area too, if you find that there is that kind of stratification. But again, it really depends on what your science question is. You know, you could collect tons and tons of measurements if you want to at all different depths.
That's really interesting. And working with someone to understand the conditions that the spiny lobsters that I used to study may experience in the kelp forest habitat. And so he went out monthly and sampled at different depths in different places off the shore and found some really interesting evidence of upwelling. You know, off the coast of California here, it's eastern boundary current. So we have this deep water that comes up over a seasonal time period. And he ended up finding out that these animals experience relatively low pH conditions, you know, just at some normal courses throughout the year. So it really is interesting to see, you know, these different measurements at different depths. And if you're thinking about biological impacts, understanding the depth range of your organisms that you're interested in, and that can help inform, you know, your understanding of what they're experiencing and their potential sensitivity to ocean acidification conditions. So thank you all for your questions. Continue to add those to the chat if you have any more. But I have just one last question for Sophie and Adrienne. You know, we've covered so many different pieces of advice and today, but I was curious if you have any other last tips or, you know, pieces of advice for those who may be starting out doing monitoring of carbonate chemistry, especially if they may have a go on in a box kit. Is there anything that you wish you would have known when you started out in this field, or that you've seen others you know, do that they could improve upon after learning a little bit more?
Yeah, I would say number one, don't be afraid to ask questions and to reach out to people who have experience doing this. You know, the ocean carbon community I have found is just very friendly, very open, very collaborative, and there's also great opportunities through their peer-to-peer network to actually get connected to someone, you know, that has an interest in that, who really wants to help you with it. And that's free advice, you know, don't pass that by. It's a really great program especially for helping folks get started.
Yeah, definitely. I agree with that. I mean, I've have to tell myself to ask for help too a lot of times. You always feel like you're like bothering the person, but I think, like Adrienne said, the ocean carbon community is pretty approachable and nice and wants to help out. So just reach out and ask for help. I think for starting out with the Go On in a Box kit, I would say to try to pick your site really carefully, and maybe ask someone, a scientist who's done a lot of deployments, to look over the plan that you have. Try to think of, try to write out your sampling plan, and just consider all the factors before you just, go out there and like hit the ground running. Put the sensor out there and to start taking samples, and you don't really know what question you're asking or that kind of thing. So yeah, just to do a little bit more prep work, or make sure you do a lot of prep work.
Yeah, that's such good advice. Getting out to the field can be challenging, so making sure that you have sufficiently planned is really important. For anyone working on their Go On in a Box kit application, if the Ocean Foundation are willing to provide feedback, we can connect you with some of the expert lectures to continue working through that. And then, of course, as we continue training for those selected recipients, there's the opportunity to continue to refine the plan as well and hear from others who have a lot of experience carrying out this work. I think this is a perfect example of both of you here with us today about how welcoming the community is to those of us who are new to the topic and building it. I've really found that to be true since I started working on ossification, and I think it's been very clear during this course too from everyone that's been very open with their time and their expertise. So thank you both for joining us for that. For the participants, I'll just remind you that the deadline for all the quizzes is now April 25th. So if you've missed any in the past, those are now open again for you to have the chance to go back and complete the modules, as well as, of course, the quiz for Module 6 that we're covering right now. Next week is our last week of the course. We'll be covering biological observations in the field, so how to complement your carbonate chemistry monitoring with the biological implications as well. All right. Thank you, everyone. Have a good rest of your day.
Bye.